Okay, so the objective for today is that the viewer will be able to use the area model to successfully multiply two-digit by two-digit numbers. We're going to start with an easy problem and work our way up to the two-digit numbers. Remembering back to length times width equals area, then we can use that to help us with simple facts and bring it up to the area model for larger facts. If we take a simple fact like 5 times 4 and think of it as 5 times 4 equals area, we could take this rectangle and we could call this side 5 and this side 4, and we could divide this side into 4 rows of 5. That shows us that we have a grid that is actually the area, and if we counted them all up, we would of course get to 5 times 4 equals 20. Now this area model is great for beginning your multiplication, but when we want to work with harder numbers, we don't want to draw the whole grid. So we use an area model that simplifies it into tens and ones. If I use the rectangle once again to do something like, instead of 5 times 4, let's make it 56 times 42. You still could think of it as area, but you are now thinking of the tens and the ones and separating them, because even when you get to the standard algorithm or partial products, you need to do that. So we will separate this, and you can divide it up so it's a little bit, smaller for the ones and bigger for the tens if you like, but it doesn't really matter. 56 is the same as 50 plus 6, and 42 is the same as 40 plus 2. So this provides our two sides. By not drawing all the lines, we're obviously saving a lot of time. It would be useless for you to draw 56 rows or 42 rows and 56 columns. So now what we can do is, if we think of this vertically, when you start multiplying, when you get to the actual algorithm, you start with your ones times your ones on top, and then ones times tens. So when we start multiplying this, we're going to do 2 times 6, which is 12. Then we're going to do 2 times 50, which is 100. These partial products would actually be ending up over here as 12 and 100 underneath, to add them at the end. Remember, these plus signs up here tell us that yes, these parts need to all go together when we actually finish the problem. To again mirror the actual partial product and standard algorithm, we then need to move towards tens times the ones on top and tens times tens. Now as we do this, we must remember our tens rule, that if I'm doing 6 times 4 tens, the 0 indicating tens, I need to include that placeholder to actually make it tens. So the basic fact is 6 times 4 is 24. With a 10 makes it 24 tens by using this 0. Over here it's tens times tens. And when we think of tens times tens, well, 10 times 10 equals 100, and we have 2 zeros there to make it get to the hundreds place. So we're going to do the basic fact of 5 times 4, which is 20. And because I have 2 placeholders, because it's tens times tens, making it hundreds, I will put 2 zeros on the end, making this 2,000. These two parts would of course have been in our partial products as well, with 240 and 2,000. I like to write it right underneath the problem as I go, because it helps me line everything up rather than at the end where I'm trying to get everything lined up. If you line up things incorrectly, you're going to get a very incorrect problem. Now, if I add this up, we will get our final answer. 2 plus zeros is 2, 1 plus 4, 5, 1 plus 2, 3, and 2 plus nothing, of course, is 2. Our answer is 56 times 42 equals 2,352.